right? You can go second, third, fourth. Are you ready? All right, let's do it. What you got?
Number 24 on page 43.
Page 43, number 24. Wonderful. All right, so page 43, number 24. Here's what it says. It says a competitive college runner, all right, ran a 5K race in 15 minutes, 23 seconds. What was her pace in miles per hour? All right, so she ran 5 kilometers in 15 minutes, 23 seconds. And I'm here to tell you I am a runner, and that would be competitive. All right, that is for sure. I just got through running myself. That's why I'm so hot. All right, I got that 6-mile loop over there. So it wants to know what it is in miles per hour. You see, that's where we're going with this 5 kilometers in 15 minutes and 23 seconds. All right. Well, again, we got 2 things here. We've got hours and we got minutes. What do you want to, miles. What do you want to deal with first? You want to do what? Kilometers and miles, that's what she wants to do. So I'm going 5 kilometers. Now, I'm going to go look in the back of my book. Why? Because King told you on the test, if you go from a metric system to a standard system, that I'd give you that. All right, so let's do it. What is the kilometers to mile thing? 1 mile is 1.609 kilometers. Is there anyone here that has not located that value? All right, again, that would be somewhere on your test. You would just be able to look it up. All right. So now the kilometers are gone. Now we are in miles, all right, and it wants to know a time in miles per hour. So do you want to go ahead and solve for miles? So that's going to be 5 divided by 1.609, which is what? 3.1 miles or thereabouts. All right, so we got our miles. Fine, let's just check that off. Now let's do hours. Well, 15 minutes and 23 seconds. Why don't we go ahead and convert everything to seconds? See, that way we don't have minutes and seconds. All right. So 60 times 15 is going to be 900 seconds plus another 23. So 923 seconds. So what have I done? I've just said, let me get my unit consistent. See, that's a very important thing. Unit consistency. So I've got everything in seconds. So now I need to go from seconds to hours. Does anybody have a bright idea on how that's going to work? Okay, you want to go seconds to minutes. Okay, so I know that there's 60 seconds in 1 minute. All right, and then she tells me she wants to go from 1 minute. That ain't right. 60 minutes, all right, is in 1 hour. And that's going to be gone. All right, so 923 divided by 3,600, that's going to be 0.256 hours. Okay, 0.256 hours. So how do I get a miles per hour? There you go. So 3.1 miles per 0.256 hours. 12.1. So this person, if you were in your vehicle and you were following her for this 5K run, you would be going 12.1 miles per hour. All right. Pretty good speed. Pretty good speed. Is anyone here a runner? Now, like when I run, I'm going like 6 miles an hour. On a good day, 6.5, right? This is running. All right. Certainly not a leisure activity at 12.1 miles an hour. All right, what else have we got? Did that clear you up? Wonderful. What you got?
22F.
22F. I love this. You guys have very specific questions. All right. That shows me you've been thinking about this. All right, so 22F, again, we're on the same page since we're only in one chapter. This is a good one. 4.5 times 10 to the fourth cubic feet, and we're going to take that thing to a cubic meter. First thing, let's talk a little bit more about volumes here. A volume is always a cubic something another. Okay, so if you wanted to take the volume of this room, like, you know, and let's just assume, okay, that it's a rectangular room. How would you do it? You would do length times width times the height of the room, right? All right, so generally a volume is length times width times height. So that would be, for an example, feet times feet times feet, which would be what? A cubic feet, if you're doing the dimensional analysis, right? And I mean, certainly you can't sharpshoot me. I know there's little bitty undulations and things you would have to really take into account. Okay, so same way with a milliliter, all right? What a milliliter is a cubic centimeter. So if you're talking about 1 cc, 1 cubic centimeter is the same thing as 1 milliliter. That's talking about if you had a cube this big by this big by this big and filled it with water, that'd be a milliliter. All right. So in a hospital, the medical profession uses cc. The chemistry profession uses ml. They are interchangeable and completely synonymous. All right. So that's the first thing is deal with, we got a volume. So this is a volume, a cubic foot. All right. Now if you were an engineer, they like that stuff. Cubic feet, pounds per cubic feet, all this. Now, cubic meters is where we're going. So, 4.5 times 10 to the fourth cubic feet. Now, can somebody look in the book or know of a way to get me from feet to meters? And we may do it in 2 or more steps.
You're going to take and convert it into, I guess, a longer scientific notation and go from inches to centimeters back to meters.
Okay, you want to go to inches. Let's do it. I know that in 1 foot, how many inches we got? 12. Wow, man, you guys are picking it up. All right, well, that was a good idea. All right, now, look at this. Will that feet and that cubic feet cancel? No. What would cancel? You would have to cube the whole entire scenario. All right? So that will make it cancel. Now, whenever you put a cube, just a little algebra review, whenever you put a cube outside of a parentheses, you not only have to cube that number and that number, you also have to cube the units. And remember, cubing is 12 times 12 times 12, not 12 times 3. You with me? Okay. All right, now what do you want to do? You want to go to inches, and what do you want to do, centimeters? So I know in 1 inch there are 2.54 centimeters. All right, and we have to cube all of that. If there is one thing to memorize in this whole entire chapter, it is that number right there. 1 inch equals 2.54 centimeters. All right. All right.